Before we start, I would like to make just a few practical notes. The webinar will last approximately 90 minutes and it will be recorded. We will we will begin with short presentations from each project, followed by a joint discussion and Q&A session. So please feel free to write your questions in the chat or Q&A box during the presentations. We will collect them and bring them into the discussion later. And of course, we encourage you to interact, engage, share your reflections, and use this opportunity to connect with the projects. So, agriculture is currently facing multiple pressures: climate change, labor shortages, safety risks, economic uncertainty, and of course, the need to produce more and sustainably. At the same time, new technologies are developing very quickly. Artificial intelligence, robotics, sensors, augmented reality, and decision support systems are becoming increasingly relevant for farming. But there still remains one important question. How do we make sure that these technologies are not only innovative, but also useful, safe, accessible, and meaningful for farmers in real-life conditions? So let's begin by hearing from each project. Our first presentation is from AgRimate. AgRimate focuses on the development of predictive and decision support models with a strong emphasis on interaction, user experience, and the practical use of digital tools in agriculture. We are very pleased to welcome Leir Bastida from Technalia, coordinator of AgRimate. She is currently the head of the Visual and Multimodal Interaction Platform. She has extensive experience in research projects, having coordinated and collaborated on several projects at both international and national level since 2002. She has published several original articles in international journals and conference proceedings, and her research interests include themes of augmented interaction, multimodality, extended reality, human factors, user experience, and person-centered design, gamification, and the Internet of Things. Quite a few. Lear, the floor is yours.
Okay, so thank you very much, Jenny, and thank you very much for inviting AgRimate to this webinar. I am very happy to be here. So, as Jenny has mentioned, I am the coordinator of AgRimate, and I will provide you a general overview of what we are doing in this project. In fact, we have last week a meeting here in Bilbao. So it was a very exciting project where we are having a lot of advance. So this presentation will be a general level, but if you have some specific question, please feel free to ask me. So what is AgRimate? So AgRimate is a project that is designed to boost efficiency in agriculture. And we are focused on enhancing the working conditions mainly for smallholder farmers. And also one part that is very important is all the part of SSH, where we want to strengthen the support networks and the community creations so they can share not only the knowledge, but they can also share business models and the technology implementation and uses in the different farmers. The key technologies we are using here, this is common to all the sister projects, is augmented reality, and we are using augmented reality for real-time guidance in pruning. We also use robotics to automate labor-intensive tasks. We have autonomous robots and exoskeleton. I will explain later. And of course, we are using artificial intelligence to ensure to provide intelligence to these systems. So, which is the main goal of AgRimate? The main goal of AgRimate is just to we have focused on the pruning process. Because it's a critical activity in different crops just to maintain the health, the productivity, and the longevity of crops. And we are focusing on two different kinds of crops that are traditional olives and grapevines. So why we have selected these two different crops or use cases? So we have selected traditional olives because they have a high variable tree morphology. And this requires different automation technologies that are able to adapt to this high variability. And also, traditional olives is focused on centuries-old trees, and they have different kind of growth patterns. So they present with different unique pruning challenges that we need to face in the development of the project. About the grape jars or vine jars, of course, they are very different from traditional olives. They have uniform growth, and they provide an structured environment, so an autonomous pruning through a robot is more easier. And also, it is easier to identify the optimal pruning points due to the shape of these grapevines. So the application of AI-driven system is easier than in traditional olives. Why we have selected these crops? Well, so we have selected these crops because they have a significant economic and cultural value in these target regions, because the traditional oil is in Spain, in the south of Spain, and the grapevines is in Greece, in Athens. And these different kind of crops help us to demonstrate the scalability of the technology we want to provide across the different kind of agricultural settings I have explained. So this is just a comic we developed for the proposal where we try to explain what we are trying to aim here in AgRimate. So in the pilot of vine jars, we are focusing on Sabatino variety. So as you can see, we plan to develop a whole autonomous robot system that is able to identify the vine jars and then to decide how to do the pruning and where to do the pruning. Okay. Also, the idea is just to have some kind of, initially, we'll have two kind of robotic arms. I think I will explain later. We have two robotic arms that will be in this kind of AGV. So they do the manipulation and the pruning of the different spores. So just a quick contents about vine jar pruning. So here we have different information. You can see different data or different parts of a vine jar tree. So we have the canes, the nodes, the cordon, and we need to focus on the spur part. So it is very important to do the pruning in the correct locations, because we are focused on the renovation pruning, and we need to help to maximize the production and the plant health. So analyzing the rules for doing this pruning are very complex and hard to model, because every plant is different. And sometimes, as you know, this is done outdoors. We have limited space and we have some different kind lighting dimension that can also affect how we use the cameras to collect this information, to process the information about what to prune. So the challenge is that we want to go from this one to this second image, okay, where the prune is done. So first, we are training our models, our artificial intelligence models, to try to identify where we need to do the prune and how we need to do the prunes. And after that, we'll have the robotics part that, using this model, will be able to do the pruning alone, autonomously, okay? So this is the part of the vine jars. So about the traditional olives is a bit different, because we cannot include here an autonomous robot. So here we are working with exoskeletons that are helping the farmer to do the pruning. And also we are using augmented reality guidance to guide the expert, also the farmer to know which kind of branch should be pruned and why. Okay, here we have also combined the part of well-being. So because normally these people, they are small farmers, so they work alone. A lot of times they are alone in the field. So we are also trying to measure aspects related to fatigue. So we can recommend the farmer to take a break, or for example, to stop working due to, for example, to the summer conditions, something like that. So taking care of their health. So here, our main focus is, as I had mentioned, on the augmented reality guidance in the field. So the idea is to provide information about where to do the pruning, but also to provide additional information about, for example, which are the conditions, the light conditions, the temperature, and the well-being part. Here, the idea would be to have a tree, a traditional olive tree, and we will be superimposing virtual cat marks on tree through augmented reality. And the decision about where to do the pruning and how to do the pruning will be done by the farmer himself. So that way we also learn about how they are doing and how this is affecting the productivity and long term. I would also like to mention that we are working also on a human digital twin. This is working together with another project I am coordinating, that is Fortis. It must focus on human-robot collaboration. But this part about modeling the human, it is very important because we can also understand which are the different states of the human. You can also see here fatigue, emotion, and also we can also understand the skills a level of the human, in this case of the worker, because the idea is just to adapt which kind of information and the message and how we show the information in the AR guidance based on the skill level of the farmer. So for novice, we will provide more information. For expert farmers, we will provide less information. And it is very important to have a model of this human digital twin so we can provide more specific information adapted and personalized to each farmer. And that should be all from my side, just a high overview about how we are addressing AgRimate. And as I have mentioned, any comment, any question, I am happy to answer them. Thank you.
Thank you very much, Lair, for this very interesting introduction to AgRimate. We will come back with the questions during our joint discussion. Now let's move to our second project. Our next presentation is from AgRoboost. AgRoboost focuses on boosting social sustainability in agriculture through technologies such as artificial intelligence, augmented reality, and automation, with a strong interest in supporting farmers and improving working conditions. We are very happy to welcome Dr. Dimitrios Argyropoulos from University College Dublin, coordinator of AgRoboost, who is also an assistant professor in UCD School of Biosystems and Food Engineering. He leads the D Lab, Digital Agriculture and Bioresource, with focus on the application of smart systems to the agri-food and bioresource sectors. He is currently the UCD Program Director of the Master Digital Technology for Sustainable Agriculture and the Principal Investigator with the UCD Institute of Food and Health. He is Associate Editor of Elsevier Journal on Computers and Electronics in Agriculture, Associate Editor of Elsevier Journal on Smart Agricultural Technology, and Associate Editor of the American Society of Agricultural and Biological Engineers. Dimitrios, please go ahead.
Jenny, thank you so much for the very precise introduction of my background. Just to highlight also that we have a special research focus on our group on mushroom farm automation, smart mushroom farming, and computer vision, AI, and robotics with specific applications to solve real problems in mushroom farming. Now, about AgRoboost. AgRoboost is another large-scale €5 million project with 18 partners across 11 EU member states and non-EU countries. Our consortium is a truly multi-actor partnership and has a wide range of actors. It consists of international research institutes, universities, technology providers, farmers and their associations, representative groups, and non-profit organizations. We take a holistic, systems-based approach for boosting social sustainability and increasing the safety of workers in agriculture. As the other projects do, we develop robotic AI and AR solutions, and these solutions are being demonstrated across 6 pilots addressing current and urgent needs in agriculture. Specifically, we're going to develop in AgRoboost autonomous robotic systems for harvesting strawberries, autonomous vision-guided robots to harvest mushrooms gently, AI-based robots for tree pruning and flower thinning in orchards, mechanical autonomous selective weeders, autonomous management of poultry production, health and welfare, and last but not least, robotization of understock weeding and mowing in steep slope viticulture. AgRoboost has kicked off successfully at the University College Dublin last December. Is a new project, December 2025, bringing together 35 participants from 18 partner organizations across Europe. But why AgRoboost is unique? Let me probably give a very brief background on what we are going to solve in this project, and I suspect in the other project, in the sister projects as well. The ILO, the International Labour Organization, notes that agricultural work employs a massive share of the global workforce. It specifies that the sector employs about 1/3 of the world's labor force. Also, the ILO ranks agriculture as one of the three most dangerous sectors to work in globally, alongside with mining and construction. According to a recent survey released by Eurostat, the European Union's agricultural labor productivity index saw a year-on-year decline of almost 7% in 2023. Having said that, in AgroBoost, we believe or we consider technology as an enabler, not a replacement. We believe that digital and data technologies may offer solutions to labor shortages by improving operational efficiency and enhance overall working conditions. In other words, AgroBoost is about harnessing advanced technologies like robotics, augmented reality, artificial intelligence, and automation to address a double challenge that we all of us face nowadays: social inclusivity and social sustainability. And let me make a very clear statement here. Our goal is not to replace farmers by robotics and AI. The goal is to empower them with new technologies. Therefore, moving towards our objectives, AgroBoost explores a future where technology helps farmers to work more safely and with greater dignity, to use fewer inputs and reduce environmental pressures, manage complex data and decisions in real time, and finally, this is a very important point, to open new roles and opportunities for those who have been left at the margin of the sectors, especially women, young people, workers with disabilities who are still underrepresented. Having said that, our specific objectives are to design and develop groundbreaking solutions that enhance working conditions, to revitalize working conditions by developing integrated AR and robotic solutions, empower sustainable agriculture through automation and enhance AI capabilities, validate and demonstrate the effectiveness of the proposed technology innovations under real life environments and settings. And last but not least, of course, consolidate international and European links, raise awareness, promote multi-stakeholder cooperation. A very good example is the event that we have organized today with the sister projects. As far as our work plan is concerned, AgroBoost is a pilot-driven project and is organized into 6 work packages. Work package 1, of course, is led by us in UCD, which guarantees successful management of the project, includes risk mitigation, problem solving, as well as quality, technical, and scientific coordination. Also ensures that the project complies with ethics and regulation. Work Package 2, led by FIBL in Switzerland, identifies technology and user requirements, also develops socioeconomic methodologies to enhance working conditions in agriculture. Now, more towards technology, Work Package 3, led by Inestec in Portugal, is dedicated to augmented reality and robotic solutions for increasing safety and improved performance, while Work Package 4, led by DTU in Denmark, focuses on automation and artificial intelligence for environmentally and socially responsible practices. Work Package 5, led by the National Technical University of Athens, is the heart of AgRoboost. This work package focuses on pilot and use case scenario design. Also, assess the performance of the digital and data-driven solutions developed earlier in work package 3 and 4 in real-life farm environments. Very important point. To sum up, our technology offerings include autonomous robotic systems, AR-based control algorithms, gamified virtual reality environment for robotic systems, AR-powered operational and training for sustainable agriculture, training the next generations of in farming, deep learning for complex scene recognition, animal-robot interaction, human-robot collaboration for safe working conditions, automation and AI innovations for path planning and navigation control, and last but not least, XAI-enabled decision support for socially responsible agricultural practices. But AgroBoost is not only about hardware and software. It is also about business models, analysis tools, and training curricula. Very, very important point that can ensure real uptake of innovations. AgroBoost connects skills, economy, and policy. How? We plan financial support to third parties through an open call. The projects will open its doors to a wider ecosystem of innovators, startups, and user communities who can test, adapt, and improve the solutions. Lastly, Work Package 6, led by Martel in Switzerland, manages communication, dissemination, along with exploitation aspects. Now, before closing the presentation, our methodology makes what I have said very concrete. We have 6 pilots across 6 different countries, covering very different realities of European agriculture, like tree pruning and flowering thinning, some of the most physically demanding and repetitive tasks in orchards, mushroom selective harvesting, requiring precision, speed, and difficult working conditions in very harsh environments, highly humid environments. Automated weeding, where robotics and AI can help reducing herbicide use and protect soils and biodiversity. Strawberry gentle picking, a crop where labor shortages are acute and product damage is very costly for the farmer. Livestock farm management, where digital tools can improve welfare traceability and resource efficiency. Crop monitoring in steep slope viticulture, an area where safety risks and climate vulnerability are very high. You understand here that these are not theoretical use cases. They are exactly the situations that many farmers and workers across Europe face today. It is one, I would say it is different. It's one thing to demonstrate a robot in a controlled lab environment, and it's another to integrate it into the daily reality of small and medium-sized farms. Another example is one thing is to develop an advanced AI model, but another is to ensure that the benefits are accessible to a cooperative in Greece, to a family farm in Ireland, and or a producer organization in Portugal. Now, about our impact, AgRobust impact. We are well aligned with EU priorities. We aim to shape Europe's digital future in agriculture, at the same time reduce emissions and also prevent environmental pressures and shocks. As said, very important aspect in our project, we believe that digital technology is an enabler in this case, with the farmer at the center. We support through AgRoboost, we aim to support women, youth, and workers with disabilities in agriculture. We have a very strong social dimension in the project, and we move from pilots to wider adoption. We deliver integrated solutions which have been co-created with those who are going to use them under real life conditions and across different and diverse territories. We aim to strengthen agricultural skills by providing analysis tools, and very important, training curricula to avoid or prevent the digital divide. And last but not least, we aim to make the farming profession more attractive to younger generations by creating skilled jobs in programming, maintenance, also delivering curricula on data literacy and support agricultural advisors across Europe. Thank you so much.
We thank you very much, Dimitrios. That was a very useful overview of how smart technologies can be connected not only with productivity, but also with the social sustainability and inclusion in agriculture. Now, let's continue with AgRibot, our third presentation. AgRibot is working on robotics and augmented reality solutions for real-world agricultural operations, including tasks such as weeding, pruning, and harvesting. We are very pleased to welcome Gregory Migdakos to present the project and its work. Gregory serves as the project coordinator of AgRibot, representing AgroApps, a company specializing in AI-powered digital solutions for the agri-food sector. In this role, he oversees the overall coordination of the project and drives the development of the Farm Management Information System platform, FMIS, one of AgRibot's core outputs. Am I right, Gregory?
Yes, I
Okay.
wouldn't say it better myself, Jenny. Thank you for this kind
Okay.
introduction.
Floor is yours.
Thank you very much. And allow me to give you a quick, I will try to avoid overlapping. You understand already Leira and Dimitrios have highlighted the reasoning behind. Just a quick recap that AgRibot is an 18 partners, again, project. We have been working on top of similar, let's say, issues and drawbacks of the European agriculture. If I may add, let's say, my 2 cents here, further from what has been already highlighted with regards to food security, with increased productivity and so forth, we need to take into consideration that farming is one of the most dangerous environments. According to Eurostat, we have 5 to 6 deaths in agricultural environment per 100,000 farmers, and we have more than 500 accidents, significant accidents yearly at the parcels while they perform their cultivation activities, with half of those related to the use of vehicles or machinery in the farm. So this makes it far important for all 4 projects that will be presented here, and this is why we are glad to be working on this, to develop, deploy, and validate solutions that address the cultivation issues, the cultivation barriers, the cultivation blockages that different crops are having, but also to allow to mitigate labor shortage. We know that several seasonal workforce is involved also in cultivating and supporting the agriculture in Europe, and also to assist all those under the green sustainable environment. So at the end of the day, what we are developing in AgRibot is, let's call it 6+6 individual components. Equally to the other projects, we have 6 AI-driven robots. We focus on the weed identification and spot spraying in cereal crops. We're looking on spraying for voluntarily potatoes and weeds in potato crops. We support the autonomous or semi-autonomous fertilization management in leafy vegetables, the precision application of activities and ingredients in soilless tomato cultivation, a sector that is increasing in Europe, the autonomous robotic harvesting in orchards, and of course, the important has been highlighted already, the pruning and thinning in orchards. But further from those, we complement those 6, let's say, robotic platforms and manipulators with 6 main blockages with regards to how can we assist, how we can support farmers and the different stakeholders into indeed adopting and utilizing those. So one had as 7th, as the plus elements, we have the use of AR, XR technologies. It is very important to us because we see people retiring. We have a high, quite, let's say, high needs farmers in Europe, and we have new new farmers entering this landscape. This means that there is a knowledge gap, there will be lack of training. We know this beforehand. So we need at the same time, through innovative technologies, make on one hand agriculture more interesting for them, but also train them more quickly, both in terms of how to improve their cultivation, but also how to use all those new solutions. So on one hand, we use AR and XR development for supporting this training and onboarding, let's call it like that, of farmers, but also on the other hand, to put some space between the farmer and the machinery. I remind you the statistics that I referenced earlier with regards to the amount of accidents that take place. So using the AR and XR, you will also see later on, we will validate those cases. Can we distinguish, can we take the farmer, the end user out of the parcel and decrease the percentage of accidents that may happen? At the same time, we have safety standards. Why we have safety standards? Right now, we know that legally the regulatory framework does not allow for total autonomous activities in agriculture. But given the increasing number of robotic platforms that are being developed out there, we identified that there is a lack for a framework that any developer can quickly go through and say, yep, those are points that, according to the upcoming certification and legal framework, do I need to abide? Those are points that I need to take into consideration. So we are allowing the new entities to develop new robotic solutions that can indeed be safe for the general end users. The third block has with connectivity boost. What we have experienced, and I think also in Greece, but also throughout Europe, is that urban areas are high in terms of connectivity, but we are still lacking high bandwidth connectivity in rural areas. What we are developing here is, or for all 6 solutions, we're developing offline versions. So can we make what we call the film platform to work totally offline? Can we support for the uptake of those solutions in areas where either limited connectivity or no connectivity it is? And on the other hand, we are deploying and we are testing alongside with Nova, a telecommunication partner in Greece, the deployment of a farmers community network, a 5G MPN network that is managed, stored, used, and capitalized by farmers communities throughout Greece. I mentioned earlier that we need to connect all those. We need to connect the AR, XR, we need to connect the connectivity, we need to connect the robotic solutions, and we need to make all those familiar to be used according to what we perceive that farmers have already familiarized themselves with. So we have upscaled what we consider as traditional farm management information systems. We now deploy them and we under the visioning firm, where the intelligence of, let's call it traditional farm management information systems, only with sensor data, satellite data, weather information, calendar activities, and so forth, comes to bridge this knowledge gap or this familiarity gap with the connected services of the robotic solutions. To allow all those blocks and the exchange of data, whether we have different proprietary platforms or we have open platforms and so forth, or different vendors throughout this, we also have one component that's called data sync, where we developed a multi-cloud orchestrator and data lake, allowing any actor within the agri-food landscape, whether it's technology, robotic solutions, digital services, and so forth, to have one central mechanism that they can infuse data, connect so that they are interoperable, but also at the same time to allow farmer to be indeed the owner of data. Through the multi-cloud orchestrator, the farmer can export data, move them to any type of vendor, whether he or she decides to move towards another one, and still be able to use all the other surrounding services, whether those are digital services under field, whether those are robotic solutions and so forth, but also to combine under a greater perspective, even swarms of robots. One is harvester, the other is mover. One has to do with logistics and moving and so forth. Apologies. And because no matter how many, let's say, things we present, we validate within the product, the projects and so forth, at the end of the day, further from tangible outputs, we need always to be in position to answer. If farmer X adopts this robotic solution for their specified farm, what is the expected impact, not only in terms of soft or social aspect, but also in terms of monetary values and economic values of adopting and utilizing those robotic solutions? Will it be financial savvy for them to use it? And on that front, alongside with our colleagues from University of Copenhagen, we have developed an impact assessment tool that will be soon available online for anyone to use, where any farmer, any cooperative, or any end user that is intending to use a robotic solution or is interested to check the market with regards to robotic solution, we'll be able to insert a simple line of data. I will show you a glimpse of it later on, and take simulation data on what exactly will be the main benefits for their agricultural enterprise at the end of the day. So let's go very quickly on top of the pilot cases. The pilot case one has to do with, as I mentioned earlier, with weed identification spot spraying. This is run with Agricultural University of Athens. The challenge here has been referenced several times, is weed identification and management. What we compare towards now, you know, the practical, there's a farmer, there's a tractor, there's the equipment, and enters and uniformly, in most cases, performs herbicide spraying. This is further from, let's say, labor-intensive safety reasoning, and is also environmentally damaging and not financially viable. So the robotic solution developed and validated and will be openly demonstrated soon by Agricultural University of Athens aims to use exactly that. Use the machine vision, identify where weeds are present, and perform the precise spraying in order to make activities as much as financially and environmentally safe. At the same time, even if it is a robotic solution, if it is a high, let's say, a high precision spraying, we still retain the farmer outside. The farmer using an AR handset can navigate the robot, can control the robot, can approve the robot activities, and distinct, because we are, in all cases, we are retaining the human in the loop. Even when in cases a machine vision model or anything else marginally fails, he can check and say, yeah, this is wrong acquisition, this is wrong activity, and so forth. Second case that we are running in Switzerland and Denmark is the robotic spraying for weeds in potato crops and volunteer potatoes. Here we have AgRobotics and DTI working on this. We have the combined use of drone images and the ARA spraying. What is the issue? Further from the weeds that we have also classified in previous case, we have also volunteer potatoes. Volunteer potatoes have escaped, let's call it like that, from previous season. And it's hard to manage with traditional means because they are very antithetical to the crop itself. So what does this combination do? The drone manages to make an initial assessment whether it is indeed the proper time to enter with the ARA machinery, and the ARA machinery on the fly detects which weeds need to be sprayed, which are volunteer potatoes and needs to be sprayed, and so forth. Again, the farmer is at the end of the spectrum. He gives the final check. And of course, all those result in dramatic reduction of agrochemical, but also in terms of labor and so forth, consumption and so forth. Now, when we're moving to our colleagues in Italy, here we have a pilot case on fertilization management for leafy vegetables in open fields. Here, the Politecnico di Bari, alongside with CNR, are aiming to address a very specific and very tough activity, the fertilization management in open leafy vegetables. The robotic solution, the robotic platform deployed, navigates autonomously in the field. That is, as you can see also, the picture is not very straightforward. It's using AI and sensors to estimate plant biomass, the canopy structure, and so forth. And according to those figures and algorithmic estimations, applies the proper amount of fertilizer, aiming for a variable rate application according to what the different leafy vegetables actually require. At the end of the day, what we have again a more precise fertilization application that reduces environmental footprint, but that again puts the farmer outside the path. I mentioned earlier that we are also addressing an increasing, let's say, agri-food and agriculture sector, the soilless cultivation. So we have another case in Italy where our Italian colleagues, are moving with robotic solutions within the greenhouses. Here, the robotic solution you see in the picture is being validated in soilless tomato. There is a combination of what the robot sees, what the robot detects with the rest of the sensors that are deployed within the greenhouse. Again, the use of AR and XR makes distinction of information and combination of information easier. And at the end of the day, the robotic complements the information that already the dispersed sensors in the greenhouse collects, and accordingly gives activities with regards to fertigation management and other different activities with regards to pests. There we go. The fifth case has to do with robotic harvesting, with autonomous robotic harvesting. We are running this alongside with our colleagues in KU Leuven, where the robotic platform is addressing one of, let's call it, the most labor-intensive and time-sensitive operations in Europe. We have seen large labor shortages during the last 2-3 years, connected but also not connected to the general COVID and war situation discrepancies. In this case, the robotic platform navigates within the crop, makes a first assessment inspection of the maturity of the sizing, and according to this, then gives back the option to the farmer or to the end user to select the type of fruits according to what they intend to do. So consider that this autonomous harvester can pick the right size or the right maturity depending on the current conditions, but also depending on what the order that the farmer or the cooperative needs to fulfill. Lastly, also similar to the other two projects, we have a robotic solution for pruning and thinning, two very tough activities performing. Here we have the robotic solution that will be deployed. It has, again, two legs. On one leg is to allow farmer to transfer his knowledge to the robotic solution, but also at the same time, the robotic solution to go and perform the thinning and pruning activity 24/7 within the crop, within the orchard. What happens is the robotic platform is making an extensive inspection of the trees, comes back with reasoning. I presume those buds and those branches to be thinned or pruned accordingly. The farmer detects, classifies which options he perceives as more appropriate one, dictates the robot to perform, and the robot is having a continuously learning operation according to the, let's call it, to the severity or to the strictness of the farmer or end user. At the same time, through the use of XR, it makes much more easier for the farmer to give a round view of how exactly the robot and the models structure the branches or understand the orchards in the parcel. So as this is being used, the models and the robotic solution will improve its accuracy and will be far more familiarized to the strategy that the farmer or the end user is using. I referenced early on the impact assessment tool. You see here 3 screenshots of it, and as I mentioned, it will be soon ready. For us, it was very important that we make something further from disseminating and communicating the pilot results to give a tool to any end user that wishes to enter their agricultural holding details, check their parameters, and compare what is the current status versus a potential scenario where any robotic solution is being adopted. So soon, this tool will be available for any farmer, for any stakeholder in Europe, so they can definitely start and calculate what it means for them in terms of agrochemical use, in terms of emissions, in terms of cost per hectare, in terms of labor savings, and so forth. So at the end of the day, we believe that having a view of the cost benefit for them, the adoption or to make the next step for any farmer or end user towards the new robotic available solutions will be far more easy. I will jump this Q&A and give you one last, let's say, slide of the consortium, consisting of the partners consisting of the consortium. And I want to repeat, it is a wonderful opportunity for those 4 projects right now. We have as I mentioned earlier, we have the COVID situation that we have seen the discrepancies both in terms of agriculture but also in the supply chain. We have seen the politics and what the market turbulence with regards to the war conditions in Ukraine, but also with Israel and so forth. So it is a golden opportunity for Europe to open up and to allow also in terms of regulation the actual deployment of totally autonomous, semi-autonomous, of course, first, but also on the end of totally autonomous robotic solutions and accompanying services in the European agriculture frame. We know that we are, let's say, we have smaller holdings. We know that we cannot be, let's say, as equal competitive as other third countries out there, but we have the research, we have the results, the institutions that participate in all those 4 projects can visualize through the results that it is not only feasible, but it is already out there. We're not right now discussing about potential innovations and about potential solutions, but we are showcasing and we're describing what we put into test in terms of demonstrators and not science fiction. So it's a golden opportunity for all those solutions presented both in AgRibot but also in the other projects to move to the market within the next 2 to 3 years. Thank you very much.
Thank you very much, Gregory. That was a really insightful presentation. Our final project is from AgRO-WELL, our project. AgRO-WELL focuses on improving working conditions, health and safety, and sustainability in agriculture. How? By exploring the potential of smart technologies, including AI, robotics, sensors, and digital tools. The project places strong emphasis on farmer well-being and on understanding how technological solutions can be adapted to real agricultural needs. So we are pleased to welcome Fabian Frick and Dr. Martina Jacob. We have 2 speakers for AgRO-WELL. So to start with, Fabian Frick studied agricultural economics at the Technical University of Munich. He is now a senior researcher at the TUM's Chair Group of Agricultural Production and Resource Economics. His research centers around farm performance and in particular on measurement of productivity and sustainability, as well as their interrelations and the role of new technologies in promoting farm sustainability performance. Dr. Martina Jacob is a researcher in the Technology Assessment Department at the Leibniz Institute for Agricultural Engineering and Bioeconomy, ATB, specializing in ergonomics and occupational health and safety in agriculture, with a focus on 3D motion analysis and work process optimization. Her current research centers on OSH topics such as the AgRO-WELL project, which addresses hazardous working conditions in agriculture through the integration of agricultural robotics and augmented reality to enhance workplace safety and labor efficiency. Please, Fabian, go ahead.
Yes, thanks a lot, Jenny, for the nice introduction. Yes, and thanks for the opportunity also to present AgRO-WELL. And as Jenny announced, it's going to be me presenting the project overall, and then also yes, Martina Jakob from ATP Potsdam is here to present some
Fabian,
first
sorry
results.
to interrupt. Can you
Yes.
please share your screen?
It's not shared.
It's not on presentation mode.
Sorry. This one. Is it working?
Yes.
Good.
Yes.
Thanks a lot. Okay. So yes, I want to briefly present, as the other projects, the general overview on the project. So its objectives, how is it set up, and the technological solutions that we have in the project. And as said, then we have some first results on smart farming technology, barriers and enablers. So overall, we are a consortium of 13 partners, which you'll see here on this map. We started in November 24, so we are at the end of our first reporting period actually now, and it's a Horizon Europe project, as you know. And yeah, we're scattered across Europe, where you could say, well, maybe we have a bit of a cluster in Central, Western, Northern Europe, with us being here as TUM in Germany and also Martina Jakob at ATP Potsdam. We have EuroQuality as a French partner. One technology partner is based in the Netherlands, the Health Injector, and also ZLTO as the farmer stakeholder partner in the Netherlands. Another technology developer with the Aarhus University, together with Ag Precision, and again, then a farmer stakeholder partner with Segers Innovation. And then the cluster more towards South Greece. So we have one partner in North Macedonia with the UKIM University. We have Up2Metric, who are very much into AR development in Greece. We have iKnowHow, Jenny, as our communication partner, as our technology developer for the robot. Then we have Jenny with Smart AgriHub for our communication part. And lastly, another technology partner in Cyprus, which is Cyric. So yeah, the overall objectives, well, we've all heard it. We know what the current problems are in European agriculture, that it's still a dangerous profession and the working conditions are surely not the best. So we also adopted this general objective of improving working conditions in European agriculture through development and also uptake, of course, of digital robotic solutions. So to do this, we start out by assessing the needs of farmers and also following kind of a co-development approach to involve them in the development process to address the real world needs. Then the project centers around the solutions, the technological solutions that we have in the project, and they use technologies that we've heard before: robotics, artificial intelligence, augmented reality, also sensor-based solutions for better working conditions and also better environmental outcomes. Then we also want to evaluate the effects of those technologies, so social, economic, environmental impacts of digital technologies. And lastly, this last bullet point is very much focused on the uptake, so on the upscaling. So we also want to look at, can we develop some business models around this, or maybe consumers willing to pay more for products that are produced under improved labor standards in European agriculture. We also develop training materials and also, of course, policy recommendations to foster uptake of the technologies. And yeah, coming to the solutions that we have in the projects, there's smart traps, another technology aimed at orchards. So this is developed by Cyric, the partner in Cyprus. So the idea is here to have an automated pest detection that can also help farmers to take away or to take over one of the routine tasks they have to face, and also contributing to integrated pest management. Then we have an autonomous mobile robot that's aimed at greenhouse production. So that's a robotic platform, also which can perform spraying and also pruning is the idea in mainly tomato production. Then we have animal production in there by focusing on pigs. And this is the vitality tracker, which is developed by the Dutch partner. And this is basically an ear tag that collects information on the pig's behavior and can track their health status. And we think, better animal welfare can result from this. And again, helping farmers in one of the routine tasks they have to do. Then we have the AR app, which is a cross-cutting technology focused on augmented reality, which is supposed to help farmers in training of the technologies and also interacting with the technologies to arrive at better performance of the technologies developed. And then we also, lastly, we have AI React, which is the technology based in Denmark, which is an image recognition-based technology for open field farming. And the idea is here that on the one hand, we can improve operational efficiency of the machines, but the other part then goes back to the working conditions and occupational safety aspect. That this also, for example, is aimed at recognizing when, for example, machinery operators are standing in a place where they're not supposed to stand, and which can then improve worker safety. And yes, so the overall project structure, the work package structure looks like this. So we started out with work package 1, smart farming technologies, challenger specification. So that's the part where we analyze stakeholder needs, policies, and also technical requirements. Then the middle part is essentially revolving around the technologies that we have in the project. So develop, test, adapt, co-design smart farming technologies. Then in the second step, so in the third work package, these will be demonstrated in real environments. Then fourth one is connected to the assessments or the impact assessment of those technologies. And then lastly, in this logical sequence is the market uptake, where we look at, as I said, business models, policy recommendations, and also training materials. And all this is accompanied by strong stakeholder involvement. As to other sister projects, we have this financial support to third parties, so a cascade funding, where the first call has been just closed. So this was an open call to attract any other technologies that fall within the scope of our project that we can, support with a small financial amount, and dissemination, communication, exploitation activities, and lastly, project management and ethics. All right, and with this, I would hand over to Martina.
Thank you, Fabian, for presenting the project structure. Well, being the last presenter of the fourth project, it seems that everything has been said, and I'm very delighted to see that all the other projects are also putting so much focus on the human-machine or technique interaction. As Fabian said, our project started 1.5 years ago. We have already reached step 1 of finalizing a report regarding the social issues in agricultural smart farming. And of course, all these issues have been known before when we wrote the proposal, but they have been founded again by looking at different levels of analysis, like agricultural case studies, peer-reviewed research, and EU surveys and funded projects. And we can say that there are 3 main and very important factors that need to be improved in agriculture. First, it's the health and safety status. It has been said by all the speakers before that agriculture is a very high-risk occupation with a lot of accidents, also illnesses, long-term illnesses, and the most prominent or the most fatal is the fatal accidents that happen, for example, with dealing with machinery. Secondly, a lot of farms are dying out, or every year there's a reduction of the number of farms, and one of the reasons is that agriculture is fairly low in its attractivity because of, for example, irregular working hours, low income, or world market price dependency on the income, low pay in relation to other professions, etc. So it's hard for farmers to find consecutive to take up the farming. And the third issue, which is coupled, of course, with the lack of attractivity, is labor shortages, that we do find chronic workforce shortages, especially in the growing seasons, and it's very hard to find the workers, to train the workers when they are needed. Next slide, please. Now, all the projects are focusing on technologies to support the farmers, to make farming more attractive. But before we are able to adopt all these technologies, we have to keep in mind that we do find a lot of barriers that reduce the adoption of all these nice technologies. The first one is the economic thing, that a lot of these solutions are high cost solutions, at the stage of purchase an uncertain return on investment. But we also have infrastructural barriers such as poor internet connectivity and infrastructure that was mentioned before. When you want to implement technological solutions, you need to improve the knowledge regarding the technical solutions and train the farmers. So we have implemented training, development of training material in the project. That was also mentioned before. We also have to overcome the skepticism towards new technologies. And then there are some technology-specific and especially AI-specific things such as data privacy and security concerns or compatibility issues between different devices. And these might arise fear of technology from the farmers, and especially a fear of failure or its complexity. It's not as simple to repair a smart device as it was to repair a simple mechanical tractor. And finally, governmental support could facilitate the uptake of these smart farming technologies. Other facilitators can be training programs, demonstration on farms, which is integrated in our project, peer influence and farmer networks. If we network within the projects, we can also promote our solutions. Then an infrastructural issue is, of course, to improve the digital infrastructure. Then all these technological solutions need to be customized for regional conditions. And as we all know, Europe is very diverse. And regarding the climate and regarding the sizes and regarding the habits. Then we need to look at certification and standardization, and finally give it access to impartial advisory service, which we also do with using stakeholder involvement from start on. Last slide, please. And the last slide I would like to highlight and also point out at the necessity that with developing agricultural robotics and augmented reality technologies, we need to keep in mind that there are new and emerging risks from these technologies. And I just want to mention these 4 sectors, and especially with very high priority, we need to make sure that these new technologies do not increase the risk of working in agriculture, but they reduce it. Therefore, it's very important to avoid collision and injury risks when autonomous machines are on the field. We also need to have a look at human-robot interaction, so design the human-robot interface, and make sure that data privacy and cybersecurity issues are not a new worry to the farmers. And at last, I would like to mention the medium-high risk, the technical failures. We need to make sure that field conditions do not cause hardware or software malfunctions, as agriculture is a very special field for using high-tech technologies, and we need to make sure that connectivity is available so the process is not stopped, and we should, in the end, do not produce an over-reliance on a single system to avoid component fails. I think that's enough for now. Thank you.
Thank you very much, Fabian, Martina. This was a great way to complete the project presentations, especially by bringing back the focus back to the farmers' working conditions and safety and well-being. We have now heard 4 different but strongly connected perspectives. So I would like to invite all speakers to join the discussion. So first of all, what do you see as the most urgent challenge farmers are facing today that your project could realistically help address? Would you like to start by the same series, Lear?
Yeah, later. Then should be first. AgRimate should be first then, isn't it, Jenny?
Yes.
I can kick off, no problem if needed.
Well, let's
Yeah,
begin
okay.
with
I mean,
Dimitrios.
as we have already said, labor shortages combined, I would say, with rising input costs are two of the most important challenges that we are addressing in all four projects, and AgRoboost, of course. We experience fewer available workers, higher wages, rising fertilizer and chemical prices, isn't it? And also pressure to maintain yields and at the same time reducing environmental impact. What we aim to do in all four projects, I will not speak on behalf of all, but let's say in AgroBoost, is to develop both AI and robotics solutions to realistically help. Just to give some examples of applications with precision spraying and weeding, as we have seen, and these pilot cases are across different projects, with early disease and stress detection, crop growth monitoring and tracking is very important as well, or gentle harvesting that we have seen as priority in more than one projects today. To sum up, AgroBoost can really help with more precise use of labor and management, water inputs, water, fertilizer, and chemicals, pesticides.
All right. Gregory, would you like to comment on that?
Definitely. Unless, of course, Larry is back resolving her connectivity issues, I will pass the floor to her.
Yes, of course. Thank you.
Yeah, okay, yes. I think I agree totally with the opinion of Dimitrios about the shortage task force we have in farmers. And I think this shortage of skilled labor is critical one, but it's also critical because the crops we are focusing on AgRimate are physically demanding. And also the task about pruning is also a time critical activity. So, and also if we combine this with the loss of practical know-how, because experienced workers retire, we have few new workers enter the sector. So we are losing that knowledge. So in AgRimate, we are trying to solve this challenge, making this expert pruning knowledge more accessible and scalable, not only through this kind of AI-driven decision support modules, but also providing this real-time AR guidance that is also combined with an extended reality training, where we can also train any person using, for example, a mobile, a tablet, but also virtual reality headsets to understand how to do the pruning. And then when they are in the field, they can use the AR guide. So they have more support when doing. And about the physical strain and reducing this strain and injury risk, we are assisting workers with the exoskeleton. Okay, so we think and we also try to target not only productivity and quality, that also is very important, but we are also trying to target worker well-being and social sustainability. That is something very critical in this kind of smallholders farmers. Perhaps for big farmers it's not the same, but for owners that has these small farms is something very, very critical.
Okay, thank you very much. Gregory?
Yep. I think what Dimitrios and Larry have already highlighted is absolutely correct. The common here is to address labor shortages, to address wherever this is possible, environmental performance, of course, the economics, the high costs of inputs. But again, let's see the safety as has been referenced, but also we need to take into consideration that we, at the same time, try to make the agricultural sector more interesting for new younger farmers or new personnel on board it. And we saw in this process, further from highlighting on everything else that we suggested very nicely and very concretely, and we are working on this, we need to make sure that any type of activities that we are doing is also an impact on how the new generation is perceiving agriculture. Traditionally, it was the lesser, or at least the understanding or the perception was that we had the lesser technology, although the mechanization and the use of new technologies in agriculture has been significantly increasing in the past. But I think the second part here is that we need to make sure that we allow any end users to participate in this, because no matter how much we highlight the urgent challenge or how nicely we present here in these webinars, at the end of the day, I would say the urgent challenges are localized or be member state based and so forth. So I would avoid being general. Yes, everyone is having the same issues or everyone having a challenge. I would suggest that we make sure that we go and customize each of these solutions to the pain points and barriers of the individuals. And this is the reasoning that we highlight, and we also put very high in this running development, the impact assessment tool. And was also the reasoning for putting out, let's say, 6 different pilot cases. If I may open a parenthesis, because we all 4 projects showcased different activities and different pilot cases. Those presented are not the only ones, or let's say the similarities that we see between the projects are not the only ones that are feasible as we speak. The transfer between detecting branches and flowers or fruits in pruning and thinning can be migrated into any other crop, or those crops that we already highlighted are not the only ones that can benefit from the robotic solutions. Unfortunately or fortunately, we are only 4 projects with specified budgets. So ideally, if we had infinite budget, we could also onboard infinite cases. But for sure, there are companies, there are institutions, there are organizations out there that we are doing far more and in far more crops and in far more activities. So for anyone that is considering a challenge, there is definitely a solution that can provide significant improvement in their case.
Jenny, a comment here, actually.
Yes, of course.
I think we are more than 4 projects, since we are going to fund third-party projects as well. Therefore, we develop a large ecosystem around agricultural robotics and AI.
That's true. I wanted to add this in the end of our discussion that most projects of ours will have open calls. So we're going to fund more.
Indeed. We will develop an ag robotics ecosystems in Europe, I think, by the end of the 4 or 5 years duration of our projects.
So, Gregory, are you okay with your great? So, Fabian, Martina, would you like to comment on that?
Well, not much to add. I think everything has been said. I'd like maybe to add animal welfare, which we also have the animal health tracker in the project, which can also help to increase animal welfare, which is also a big challenge, of course. And yeah, maybe one point that we need to keep in mind to also, the uptake part, so to make technologies really usable for the farmers. And I think we can also contribute to this also through the AR part that we're developing that should help farmers to really use the technology then effectively and also to train them on the technology. That's maybe the 2 parts I can add.
Okay. Martina, would you like to add something on that?
I would just like to address the AgRimate project, as I heard that they are implementing exoskeletons, and I would like to let them know that I have been doing research on the implementation of exoskeletons in horticulture for the last 5 years, and it's a very big challenge to get them accepted in agriculture. And I think that's a very good example as long as you can calculate that a machine is economic for the farmer, it's very likely that farmers will buy it. But by the time it's only good for their health, like personal protective equipment, it's much harder to get farmers used to use these kind of solutions. Thank you.
Thank you. Now our next question is what are currently the biggest barriers preventing wider adoption of robotics and AI in farming? I think that in some presentations we saw some answers on that. So please take the floor. Lear, would you like to begin with this?
Yeah, of course, I can do that. Okay, so I think the biggest barriers are a mix of different things, economical, technical, infrastructure, but I think I am going to focus on two of them. The first one is that I must say that many farms, especially these smallholders, struggle to justify investments, okay, and they don't have a lot of money. And this depends on the labor total cost, the crop size, the farm size. So doing investment in any kind of technology, they need to have a very careful analysis of cost benefit. So we need to try to develop technologies that are not very expensive and provide better benefit than the cost they have. So I mean, for example, in the vineyards, we are talking about an autonomous robot that is doing the pruning, but we are talking about the type of crop that have high benefits. It's not the same, for example, as orange or any other kind of crop. So I think that something is very, very important. Another thing is that we are applying technology in complex outdoor environments. And the reality of using this technology sometimes is complex because, for example, if we are talking about robots, they must cope with uneven terrain, different kind of variable crops, weather, dust. So that is something very difficult to engineer this kind of developments at scale. So I think I'm going to focus only on those two ones that I think are the ones we are trying to focus on AgRimate.
Thank you.
Very good. I may add here two other barriers, like one is more operational, is about the farming environment, which is extremely hard for robots, is unstructured, is weather dependent, is variable. In Precision Ag, we address both variability in space and in time. Also filled with irregular terrain, occlusion, lighting, it's muddy, it's dusty. Therefore, we need to deal with very harsh environments. Another barrier might be the skills and training gaps. I suspect, I don't know, this is probably part of our discussion here, that many farmers simply have not been trained for this digital transition. Also, many farmers in many countries, I mean, of course, I liked what Gregory said before, we should target a specific problem, not to be that generic when we speak about such issues, but most of the farmers nowadays are aging. We need to create a more attractive farming profession for the younger generations. And I feel also that the tech-oriented workers are underrepresented in agriculture. I will focus on these two variables.
Thank you very much. Before continuing, I would like to inform all attendees that they can put their questions in the Q&A section we have. So let's continue with you, Gregory. The biggest barriers?
Well, If you were asking me 1 or 2 years ago, I would definitely be, let's say, more not strict, but more, let's say, uh, less optimistic right now. We have been through the last 2 years, we have been through the hype of AI. We have seen robotic solutions on any type of sector being materialized and being demonstrated. And I would say that we have a gold opportunity here because in most cases, the majority of the people, whether they are farmers, whether it is the general society, whether it is the research and so forth, are right now, at least on a hype level, much more familiarized with it. The trouble is that all this hype is creating much more higher perception sometimes. So, as Dimitri suggested, you expect to buy a robot or to use a robot and this to go through like in 100 kilometer speed harvesting into an orchard. Yes, we have gone through several developments. We have reached the place, I think I mentioned earlier, where all those solutions can be deployed and can be utilized next day in agricultural environments. But as correctly stated, we need to make sure that those are not Harry Potter into a robotic platform. So they largely depend on the conditions that they will find. And by their nature, our algorithms, our machines, are things that increase their accuracy through time. So nothing is one time off. Nothing should not be considered as a white or black. Our part of the work is to address also those perceptions and make sure that any barriers that are left, whether it is end user, farmer, cooperatives, agronomists, and so forth, are being addressed openly by specifying what is possible, even under this hype, and what it is still under research. I think we have all been victims of this hype and tension on large, far more larger expectations than what can be delivered. But still, I think we have a large set of tangible outcomes that we can showcase and address those barriers.
Thank you. Fabian?
Yes, maybe just quickly add, I think important things have been said already, but maybe also connected to what Martina said, that with new risks coming from the technologies, we also have to take into account those. So let's say cybersecurity, right? We know that this happens regularly to bigger companies, and let's say data would be hijacked from cloud solutions for farmers. Then surely if this would happen more frequently, then this would be another adoption barrier. And also, if technology is not working, this adds to the stress of farmers, not reduces this, that we want to aim at in the projects. So also something we have to keep in mind, I think.
Thank you very much. As we are having just a few minutes left, I would like a short answer from all of you. Do you think the next generation of farmers will need a completely different skill set? Yes or no?
Not completely, but improved.
Extended, maybe.
Yeah,
Extended. Okay.
it's a better.
And I feel that the next generation of farmers will still need strong traditional and empirical agricultural knowledge together with data literacy.
Great.
Will
Yeah,
be
I think
hybrid. Sorry, just to add, will be probably hybrid skill set which combines pure knowledge of agriculture with digital and systems thinking approach.
Great. We also have a few questions from the Q&A section. Do farmers believe robots can realistically help solve labor shortages on farms? Are they concerned about the costs of purchasing, maintaining, and depreciating the equipment compared to employing human workers? Who
I
would
can
like to
take
answer
that. I can take that. I was 3 weeks ago in the Netherlands for an exhibition organized by the mushroom industry, Mushroom Days. Speaking with, discussing this aspect with mushroom farmers, they said that they will be really interested in seeing more of such harvesting solutions in this sector reaching the market. And probably they can adjust or adapt their traditional ways of mushroom farming. Therefore, at first instance, there was a positive reaction, I would say, and I was also impressed by this reaction from someone coming directly from the industry that knows the problems on a day-to-day basis.
That was a promising answer. And another,
It was an answer,
it was an answer,
but I
yes.
really, I want to mention that here because I was really impressed by this answer. I thought that farmers might be reluctant on, adopting or feeling being replaced by machines and so on. But it was really interesting aspect by a farmer being in the sector for more than 35 years now, older generation.
Okay. Even more promising if the farmer was elder.
Yeah.
So another question we have, what is the current state of integrating quantum computing into agriculture and how far has the field progressed? Gregory?
Any volunteer to answer that?
Well, quantum
Not to be
computing
answered
is
by
being,
economists.
yeah.
No. A
Well,
complex
I can,
question.
it's used. I think there are several activities where it's used, whether it's crop breeding, whether it is for weather forecasting, and so forth. I don't know if I do have, let's say, a scale to count it, whether it's on 2, 3, 4, and 5. I think horizontally, everything that is new, everything that is technology development is being used on different sectors, but there is a paradox that I want and I always express. If you consider all sectors and you consider the availability and how important agriculture and agri-food sector is, I go back and check the number of innovations that indeed originated on the basis of agriculture. Agriculture is one of the most important sectors for food security and food safety and so forth, and for sustaining us. But the majority of innovations were migrated or technology transferred by other sectors, whether it's medical, whether it's communications, whether it's anything else, to agriculture. So for a reason, technology or research-wise and so forth, we always had the impression that it is important, yes, but it can wait because it already produces food and we are fine with it. Let's move to another sector. In general terms, it's always one of the sectors where steps are being made, but I would say it's not the first one. It's not the tech lead among the sectors, but definitely the partners or the actors that are doing the research, and we have lots in those 4 projects, are continuously grasping and utilizing and validating new technologies, no matter what the form this takes, quantum and so forth.
Okay, someone else who would like to complete something? Add up? No? Thank you,
Before
everyone.
closing, let me take a screenshot.
Okay, yes.
Smile, all of you. That's great. Thank you. I will
Thank you very
share
much.
with all of you the picture later on. The
Of course.
Thank you all.
Thank you very much to all our speakers for joining today and our attendees. Today's discussion showed that smart farming is not only about advanced technologies, but also about making technology practical, safe, and inclusive. So the projects presented today, AgRimate, AgRibot, AgRoboost, and AgRO-WELL, each by their own perspective, contribute to this shared goal. And we hope that this webinar will lead to further exchanges and collaborations. So before we close, as I mentioned before, some of our projects will have open calls and future opportunities for external stakeholders with more announcements to follow. Thank you once again to all our speakers and participants. Have a nice day. That's where I was supposed to share my screen and present you our social media, but I can't share my screen.
Thank you all.
Thank you, everyone.
Okay, thank you
Thanks,
very much.
everyone.
Thank
Thank you
you.
very much.
Thank you.
Have a
Have a
good
nice
day.
day.